Thank you. So I've spent the past 3 years making consumer electronics devices, and one of the requirements that arose through that was the ability to record data out of our devices. And they ran the various operating systems from embedded Linux to while one loops and various embedded real-time operating systems. But one thing they all had in common is they could talk USB. And so, oh, USB, that's handy. You know, we all have a device in our pockets that speaks USB as well. So why not make it talk to it? So today, I'm going to give you a brief overview, a bit haphazard, but we'll see how we go, on how to make an Android device talk USB in host mode to some kind of peripheral. And hopefully you guys can take that information away and make Android talk to all kinds of interesting devices in the future. So we'll briefly go over Android as a tool, and then USB on Android, what it provides in terms of APIs and hardware support, and then how to take some existing code that knows how to talk to a peripheral and bring that into the Android land. So in this case, a bit of C code, using the Java native interface and the native development kit that the Google guys provide for Android. And then I'll go over some of the gotchas there. So the permissions model was one of the harder things to integrate in the system I had. And I'll give a second demonstration application that used this similar architecture. So Android as a tool, why is it handy? They're very cheap and portable. So most of us already have one in their pocket. If we don't, then it's $300 to go grab a pretty powerful computing device that has USB connectivity and network connectivity, which is handy. One of the other things was we were using Windows laptops to do data acquisition. We had some custom software that ran on those, but these days, Windows, you can't buy Windows 7, you have to buy Windows 8, and the software initially didn't work on Windows 8, and Windows 8 just brought its own hassles with it. So by using Android, you kind of sidestep all of those licensing issues. How do we get an installation license for a version of Windows you can't buy anymore, etc. And it's got a bunch of useful APIs. So an alternative to using Android might be writing your own custom embedded Linux system, but that would involve going and doing a whole heap of heavy lifting, getting a root file system up and running, getting some kind of input going, some kind of display happening, and lots of other work to do. Android provides all that for you, and it gives you a nice high-level IDE, usually Eclipse-based if that's how you roll, to do your development in. So USB on Android. USB APIs appeared as of Android 4. I put an asterisk there because it was in Android 3, but no one really cared about that because it wasn't on phones. So Android phones, they can speak as a device and as a peripheral. Normally, the way you use it is as a peripheral. You plug it into your PC and sync your music or copy your photos off or whatever. But for us, it's much more interesting to operate it in host mode. So that's where the Android device acts the same way as your computer. And so you can plug a USB key in it, a keyboard, or something more interesting, like a consumer electronics device. So a couple of tips that I have for you if you're going to go down this route. Most hardware requires a dongle, so something that forces the port on your phone into host mode. What that actually does is there's 5 pins in a mobile USB port. The 5th one is an ID pin that says whether to be host or not. And so these little adapters generally force it into host mode, so you don't have to have a specific device that knows how to talk that. You can make one yourself, like this image that I stole off the internet. Wouldn't recommend it though. You can buy them for a couple of bucks off eBay. Another useful tip is using Android ADB over TCP. So the Android development environment uses this protocol called ADB. It's also the tool to talk to devices. And one of the problems you have if you're trying to develop communication with a USB device is you want to have it plugged into your development PC to debug your application, but you also want to debug it talking to the USB device. So how do you solve this? Using Android over ADB over TCP is the way to go there. Alternatively, to avoid those first 2 things, you could just use something like the ASUS transformer, which has a host mode USB port on the keyboard, as well as a device mode for plugging into your PC for development at the same time. So this is a demo of one of the applications I created. So in this case, it's talking live to an embedded device and streaming out some data and doing a plot of it that helped people that needed to know these things know what was going inside the device. So the architecture of this app, we started off at the bottom with libusb. So libusb is kind of the de facto standard for talking to USB devices on Windows, on Linux and OS X, and these days even Windows isn't too bad as well. Android being Linux under the cover, your libusb just works out of the box with a few gotchas, as I'll cover in a moment. So plop libusb in there, cross-compile with an NDK, and you're off and going. On top of that is some C code. So like I said before, this is some existing code that knows how to talk to the device that you might have already written, or another open source project that you've grabbed code from. You can go and grab that, plop it in, and reuse all that logic without having to re-implement it in Java or rewrite it in C for this target. On top of that is a C wrapper. So this is a bit of code that interfaces between your existing code or existing application and lets it talk up through JNI to Java. JNI stands for the Java Native Interface, and it's a way of getting Java code to be able to call into C and C code to be able to call into Java. So up in the top half of the box there, we've got the Java code, the Android Java application. And so that's got a little class that knows how to talk down to the C wrapper. The C wrapper has to have specially constructed function names so that the Java code can call down into it. And so it can open up the device and provide a callback that the C code can then call back into when it receives data and whatnot. And on top of that is the UI. So that's a pretty basic bit of Android UI. Use the Eclipse IDE to drag and drop all your little UI elements and hook them up, and off you go. So some of the gotchas in developing that, or not gotchas, but the steps I needed to go through, the things I needed to learn to get started with that. So JNI, it's part of all Java implementations, so you can play around with it on your desktop, with your desktop Java virtual machine. And so like I said, it allows C code to call any Java code, and it allows specially written Java code to call into C code as well. It's a bit hard to get started with because the documentation out there isn't all that great. The best demonstration I found of how to use it was jumping on GitHub and looking for some other projects that had used it already. So this is a bit of a demo of what it looks like. So at the top there, we've got a very simple Java class, and so that's got a native function definition there, a method definition. And so that's saying this is a bit of code that doesn't have a Java implementation, it's got a C implementation. So you can call that from any other bit of Java code, and magic happens, and the C code gets called. Down the bottom is the C implementation of that code. So you've got a bunch of specific variables you have to pass into the function. Some of them are magic ones, so the environment, Java environment, and the class context information about the Java virtual machine that's running. And on the end is the parameter that you're passing to that method. So native development kit, that's something that Google provides as part of the Android development environment. It's a cross-compiling toolchain for Android. So you can target any of the platforms that Android supports, MIPS, x86, and ARM. I think that's all. So it uses the makefile build system. So it's pretty nice to use for embedded software developer. Jump in there and write a little makefile stub, and it can compile your C code and compile it in such a way that it integrates into the Android application. So like I said before, it allows you to reuse any existing code you've got. In our case, it's a little bit of protocol code, but it could be something as complex as a voice codec and a modem, which I'll talk about a bit later. And so those shared libraries that you've compiled are then loaded into the Java virtual machine and are accessible. So this is a little picture of what that looks like. So we've got the shared objects that exist in your file system, and then on the right there is the Java code that loads those objects into the virtual machine. So Android permissions. This is another one of the gotchas that I found. So on your Linux box, your laptop, when you get a new, say, a USB serial dongle or something like that, you might have a driver in Linux, but you won't have permissions to access it. And so usually that involves jumping on the internet and finding a little stub of how to write a udev rule so that when you plug it in, it will set the permissions correctly. Android does the same thing. It limits the device nodes access to them. But the problem is there's no udev on Android. Well, that's maybe not a problem, depending on perspective. So instead, it has its own security model. The device node can be owned by the Android application that you're running, but you have to ask the system for permission. So that looks like the little UI there on the bottom. So you register for an Android intent, and provides a UI to the user. The user clicks yes and OK in this case, and off it goes. The permissions of the file gets changed. So when I was writing this application, the existing code already knew how to discover and open the device, but I wanted to discover and open it in Java land so that I could get permission to access it. And I didn't quite know how to pass that information down into the C code so that the C code knew this is the device that we've given you permission to access, off you go. Used a bit of a hack in the end. I used the Java code to get permission, and Android effectively does a chmod on the file, and then the C code would then rediscover the same device, and because the permission had already been changed, it just worked. It's probably not the neatest way to do it. I can imagine some scenarios where something would go wrong there, but it worked well enough for the use case that I had. So that's the Android architecture of this application we created. It was pretty simple to do once you had all these little pieces together. Getting the NDK up and going was a little bit of a learning experience. Cross-compiling in general is just always a fun kettle of fish to play with. But no, it was not that bad. So at the same time as I was doing this to talk to this consumer electronics device, I was also working on working with a friend who's been developing an open source voice codec and modem. And we wanted to do a cool demo that used Android. So last year I gave a talk at linux.conf about how radios work. So this is a slide from my talk last year. This is a radio that I built myself. As you know, I'm a beginner, so it's a little bit messy, but that's okay. It worked first go. We managed to receive voice calls over the air. So that then hooked into an Android device. Looked a bit like this. So you can see some similar kind of blocks there. In this case, I was talking to a USB sound card. Android sort of supports USB sound cards, but not really. So in this case, I was using the USB sound card more as a D2A and A to D, a data acquisition and output device, and wrote a user space implementation of the USB sound card spec, just enough to be able to receive and send data at 48 kilohertz out to this device. And on top of that, we had the codec and the modem running. And yeah, we managed to get it decoding over the air. So that's another demo implementation. The reason I'm bringing this one up is that the source is online. So you can jump onto GitHub and there it is. Jump onto GitHub and have a look at that. So that's got the JNI stuff, the makefile, and how to interface it up on the Java side as well. So that's about it. Thanks very much.
Okay, so does anyone have any questions for Joel? Sorry. Oh yeah, Julian.
So there's the ADK, which is the official protocol for USB. I guess this was, you already had devices which already had their own USB protocol?
Yeah, so if you're going to think something from scratch that was only going to talk to Android, you might use the Android stuff there. But if you've got an existing device and you want to talk to an arbitrary device, then yeah, this is a bit more generic. The same code runs on a Linux box as runs on the Android box, so you can test it on Linux and off go and deploy an Android and whatnot.
With respect to the permission thing, if there's two apps that have registered an intent for USB host and you plug it in, what is it? Does it give you an option to select which app you want to use? Or?
The question was, if you've got two apps that are registered for a USB device, how do you select which one? In my case, the app would request permission to access the device. You can make it so Android will automatically discover a device and offer a list. Apps can register for that intent, so they'll automatically pop up when you plug the device in. But in this case, I'd start the app and click Find Device and do it that way. Yeah.
Any more? Russell, do you have one?
Well, I did. Yeah. So it was you've written a whole bunch of code there to sort of implement this layer. Obviously, there is also the Android built-in kits for dealing with USB devices. So how much of what you've done there could actually, when you have it, could theoretically be wrapped up as a generic interface to provide that low level, or is it really every device is going to need, or every device that you're going to need to interface with is going to be completely separate?
So the question was how much of my work could be reused, I guess. So the libusb stuff, someone else had done a little bit of work there to integrate in Android, so I'd reused his work. I guess you could use the way I'd structured it as a template for any kind of libusb-based app that you want to make work on Android. But there's it's pretty specific to the application you're using. So in the case of the radio, I guess I'd written this Android device class, bit of code. It was pretty hacky, pretty specific to the sound card I was talking to though. So maybe that could be extended and be a generic USB audio device class, little layer, but yeah, not so much. But there's something to explore, yeah.
One thing I was going to raise, by the way, when you're talking about the JNI, is that writing the interface functions in C is an absolute pain. There's code generators that you can look at for that. I use Java CPP quite extensively, and that generates all of the wrapper functions that you need to talk to your pre-existing C code.
Yeah.
It's pretty cool.
Yeah, no,
Saves you a lot of time.
Thanks. I'm a complete Java and Android noob, so I kind of hacked it together till it worked.
I'm trying to understand the permissions thing. So basically, the Android knows you've plugged something in, right? So, or the libusb.
Well, Linux knows you plug something in,
Okay,
and so
Linux knows.
it'll create a dev.
Right. And then how does this get through to, so you've got code then where the Java's asking the person, you approve of this device being plugged in or something? Then
So in my
yes,
case, my application is saying, I've discovered a device I would like access to. Can I have access to it?
Right.
So it's a way of, I guess, making sure that random applications aren't going to start talking to a device as you plug it into your Android phone.
Okay, and then Java does the chmod sort of thing? Or?
Or the Android operating system layer does that, yeah. Under the hood, that's what's happening. But, to you as a developer, you register for this callback, for this intent, and the system UI pops up a box saying yes, no, and the user will click yes or no, and then you'll get the response to that callback saying yes, you have permission, or no, the user denied you.
And then your code needs to do the chmodding?
No, that's already, but if the user has said yes, then at that point the device node will be accessible. So libusb will just go off and do its thing.
Okay.
No more questions? Well, in that case, everybody please thank Joel for his talk.